Good morning, friends. In this video, we are going to define the signal and some classification of signals here. First of all, we can start the video with the definition of the signal. A signal is a function of one or more independent variables which carries some information to represent physical phenomena. What are examples of the signals in the embed? Can take the human speech or ECG signals or EEG signals. These are the some examples here. Again, the signals can be classified into two main categories. One is the continuous signal, next one is the discrete signal. Mainly we are representing the continuous signal with respect to time period here. So from the definition of the signal, signal is the function of one or more independent variables. Here the independent variable is the time here, and we are representing the signal as the x of t. Or x of t is equal to sine omega t or cos omega t. You can take the any type of signal here. And the continuous signal, the signal that has the value at all continuous points, at all points. Whereas x of t and t is the independent variable, and we can represent the x of t is equal to sine omega t. If you take the graph between the t comma sine omega t, it has the points at each, it has the value at each every point. And we can take the example of human speech here, and we are showing the graphical representation as shown in the figure. Okay, discrete signals, it does not have the value at each every point here, so we are defining the some points as shown in figure. We are taking the 1 2 3 4 5 up to 10 values, but it does not have the value at the 1.5 2.5 like that. And how can you convert the continuous signal in the discrete signal embed? By using sampling. So if you take the one continuous signal and if you sample the continuous signal at each every 1 second, we'll get the value of the each every 1 second. And this signal is called as the discrete signal. And the discrete signal is represented as the x of n value. Okay. In MATLAB, we can use the stem to plot the discrete signal and plot to plot the continuous signals. And the figure shows the representation of the continuous signal. The left hand side signal is the continuous signal. Right side signal is called as a discrete signal. The shape of the signal will be same, but in the continuous signal, we are taking the points continuously. In discrete signal, we are taking the points at each every sampled value, nothing but at particular time period. Sampling, the sampling can be obtained by sampling the continuous signal. Simply we can say that the switching will be taken for each every some time period here. These are the main classification of signals. First one is the deterministic signal, non-deterministic signal. Second one is the period signal, non-period signal. Third one is the even signal, odd signal. Fourth one is the energy signal and power signal. Deterministic signal, the behavior of these signals is the periodicable. Nothing but there is no uncertainty at any value, and it can be represented with mathematical expression. For example, you can take the x of t is equal to sine omega t or sine 3t, sine 4t like that. Non-deterministic signal, here it is the random signal. It does not have the particular value. It has some random values here. There is the uncertainty at each every value. Mathematically, you cannot represent the random signals. For example, you can take the thermal noise. Period signal. Mostly we are taking the period signal is said to be the signal which is represented as the x of t plus capital T is equal to x of t. Uh, Nothing but it is periodically getting the same value. Suppose x of 0 is equal to some value, x of 2 pi will have the same value here. And the example is the example of the signal is cos omega t or sin omega t. And signal in the period signal, the discrete signal can be represented as the x of n is equal to x of n plus capital N. And in cosine form can take the a into cos of omega n. In continuous signal, we are taking the cos omega t. And even signal comma R signal here. From the definition of the even signal, it is defined as the x of minus t is equal to x of t here. And the R signal is defined as the x of minus t is equal to minus x of t. Figure shows the even signal, A shows the even signal, and B shows the R signal. Suppose if you have the one signal which is combination of the even part comma odd part, can differentiate the even part comma odd part by using two equations. X of et is equal to x of t plus x of minus t by 2, or x odd of t is equal to x of t minus x of minus t by 2. Okay. And energy signal, power signal. Simply you can give a small definition of the energy signal. Where the energy is finite and the power is 0, it is called as a energy signal. And the power is finite and energy is infinite, it is called as a power signal. So the energy formula is E is equal to integration of minus infinite to plus infinite x of t whole square dt. And similarly, you can take the power, but here we are taking the limit t tends to infinite, 1 by t integration of minus t by 2 to t by 2 x of t whole square into dt. Okay. And these are some classification of signals. Thank you.